All right, welcome everyone. Today I'm going to talk about how you can deploy the DeepSeek R1 model into the Azure AI Foundry and then build a very simple Python-based application to talk to that model and generate the text out of it. So it's a pretty conventional way of developing application. I have done many presentations. There are videos available which you can watch in detail, step by step. There is in fact a whole series dedicated for that. But I'm essentially want you to understand beyond what is available in Azure as a native AI model, you do have capability which allows you to deploy different other open source models, and this is one of them. Okay, and then how we use a sort of common library to build the application, the API. You don't need to learn different kind of syntaxes, etc. So it becomes much easier for an application developer. So what essentially we're going to talk about today, we'll talk about a few things. We'll talk about the basic understanding of what DeepSeek R1 model is, and then the deployment of the DeepSeek R1 model in Azure AI Foundry. Then we will build a Python-based application using the existing API which is provided under Azure AI Foundry, and using the Streamlit, we'll do a quick proof of concept where we will basically be hosting it in a web version, which is kind of easier for us to present. So this is the hero of this talk is Azure AI Foundry, which essentially gives everything you need to deploy the model. You don't need your dedicated virtual machine or a machine learning studio, something of that sort. It's a very simple way, serverless way of doing things. There are a couple of resources available, which basically is here. So you can go into the R1 model uh, and then understand what exactly you need to do, what kind of dependencies are there. Do you need a GPU machine? What GPU machine? What kind of configuration? So all those details will be here. There is an availability announcement of this model into Azure AI Foundry. So we'll see that announcement also by opening the URL. And then the API I was referring to earlier is the Azure AI model inference of Azure AI Foundry, which essentially allows you to interact with many such open source models. So we'll see that. But before that, let me help you understand a couple of things. One of the things is that let's understand what this DeepSeek model really offers to us. Okay, so what essentially means that I'm going to quickly walk you through to help you understand why it is different and what kind of things are available here and how you can leverage these capabilities into your application, or let's say intelligent application. To do that, let me change the orientation of my screen so that I can do a little drawing here. And then in that, what I'm going to do is that I'm going to walk you through this whole thing, which is now available for all of us to help with. So if you in fact look into the other model, and then if you have gone through a little bit of understanding how it works, so it primarily focuses on few major aspects. So this model, let me just R1 dip, it has got a couple of capabilities. Number one is cold start. What essentially cold start means is that it begins with a pre-trained model, let's say the version 3 of the same model, and then it undergoes through a supervised fine-tuning on a carefully curated dataset. Basically, that dataset is kind of massaged and available, and this basically aims to improve the readability and clarity with a high quality. That's what we call a cold start. Second one is reasoning, reinforcement learning. If you have to understand this, what that reinforcement learning is, in a short, if you just go a little inside that reinforcement learning, because it will keep coming back, because this is the power of this model, is that it has got a couple of capabilities. So we're not just switching to the reinforcement. So it has got like learning by interaction. So what essentially this says that when the reinforcement learning happens in a machine learning space, we have an agent which learns to make decisions. How they learn to make decision? By interacting with the environment or the world where it interacts with. The environment means the world where it interacts with. It is like a pet training. So when you train a pet, you basically give some goodies or reward the pet for good behavior or following your instruction, and you discourage the bad behavior, right? And that's how pet get to know that what is right thing to do, what exactly not right exactly, but what exactly you want him or her to do, right? And then it has got a trial and error, which essentially means that the agent explores the environment, the world where it interacts with, and try different actions and receives feedback in form of a reward or penalty, right? And based on which it takes a call. And then you have the goal oriented, which essentially means that the objective of the agent is to learn the strategy, okay, or a policy. We can call it a policy that maximizes the total reward it receives over a period of time. So you essentially increase your point by following certain strategy. So the agent is kind of capable of doing that. And the last one is no level data. Which means that unlike supervised learning, the reinforcement learning doesn't require a label data set. So you don't need to identify the data before you train them. And the agent learns from its own experience. Okay, that's what the major difference. So you kind of have heard a couple of words which are keywords, like you have got agent, you have got environment, you have got state, action, and then reward and policy. What essentially it means that these are the key concepts based on which the reinforcement learning happens in the scene. And we have explained a bit high level how these things works. There are quite a few algorithms available which helps you do those things. So for example, if you consider algorithm commonly known as the algorithms are Q-learning, you have SAW. It's similar to Q-learning. Q-learning is basically action selection strategy, and then it estimates the reward by taking the action in a given state, sort of like that. It's simplified version, but beyond that, there are many things happens internally. The SARS is sort of like a similar to Q-learning, but it basically updates its estimate based on the action taken, not on the maximum possible reward, right? So it doesn't go on that. Policy gradient method, deep reinforcement learning, these are the different types of RL algorithms available. The typical real use case applications of reinforcement learning could be robotics, where basically you have to perform in the real world task. So you need to learn from things like, if let's say the machine where the robot is working on is doing the malfunctioning, the robot should be able to react to it, and that could be a totally new situation scenario for the robot, right? So those are the real use cases. Game playing, that use like superhuman level chess, for an example, uses that, right? That you have a superhuman level agent to play the chase against human being. Autonomous driving was one such big use cases. Recommendation system is also something which you can think of, and then resource management for the industry like energy or logistics. Those are the kind of very good use cases which are available. Now coming back to our own DeepSeek-R1 thing, how it works. So basically we were talking about 4 things. So let me number them. 1, 2, and then the reasoning reinforcement learning phase. Basically it applies on a large scale reinforcement learning and enhances the reasoning capability across tasks like coding or logical problems, etc. And then the model learns to allocate more thinking time to complex problem naturally. So imagine, as a human being, someone asks you to multiply this. If you have to multiply this, you don't remember the result, do you? You don't. What do? You break these into smaller problem and then do step by step. So what we learn in the school to do this kind of multiplication is that we start from this side and then calculate. So let's say and then we do this, so, and then so on and so forth, right? So kind of like that we will keep doing it, and then the third one becomes like that, and you come up with this result over here. Okay, so that's a kind of human way of breaking problems into smaller problems. Okay, so this works on a similar way approach. So it takes one big problem, breaks it into smaller problems, and does it. And then the third one, let me put it here. The third one is rejection sampling and supervised fine-tuning phase, which is basically samples are generated from previous phase and filtered using the rejection sampling, or retain only the high quality outputs. Basically, you generate a reward model which guides this process to ensure that only the most effective ones are used for further training. So it's kind of during the training phase, you kind of enable the agent to do those things automatically. And then the fourth one is the diverse reinforcement learning phase. So this is the final phase, which basically introduces the diverse task with the rule-based rewards for applicable scenarios. That's the fourth one. So there are 4 kind of steps by which it is getting trained, right? And then it uses something called a group-related policy optimization. Let me write it down. The group policy optimization, or commonly known as GRPO.
It's an efficient reinforcement learning algorithm, basically, which used to train model like the previous one, DeepSeek-R1. And then it eliminates basically the need for separate critic model, which typically are resource heavy, right? And instead relies on a group score to estimate the advantage of the policy optimization. So instead of somebody observing and then giving the point, it actually is a self-service. So you can imagine that this kind of uses effective compute power to perform those activities, right? Now, a couple of capabilities or features of this, let's say features. So it is basically 671 billion parameter, and this is one of the largest open source LLMs available today. This is one of the largest LLMs available. The size is immense, and it has got very powerful capability. It has something called as a mixture of expert. So what is that? So the mixture of expert, or MOE, we call it, is an architecture which where the R1 version of this model employs the mixture of architecture where different parts of the model specialize handling specific type of problem. So a kind of distributed task within the model itself, right? Not everybody is doing everything. And to understand a very long piece of text is basically meant for that kind of activity. So if you supply a very long piece of text and elaborate what exactly it is written, it's something like that. So it will basically go into, it's gonna go run in parallel, so to say. And then it maintains the context over extended interaction. So it basically has a very large memory, contextual memory for that activity. And the size of the contextual memory is something around 1 to 8,000 tokens. So that's the staggering number where the context is kind of preserved. So when it basically extend the context window to this much, it can keep the history and continue to keep thinking against what it has done before. So that's the memory or the history of the context is a very long term, right? Like human being. If we can remember something at our very early stage also, and then it keeps coming back. Not everything, but at least something we can remember. It has a reasoning ability. It is designed to focus on reasoning ability. So it basically asks question to himself or itself, and then basically performs multiple interfaces to pass over a query using techniques like chain of thought, right? So it's basically to come up with an insightful, meaningful answer, right? We can go on and on about DeepSeek model, how it works, etc. But we are not going deep into that. The focus is that we will use this to build an application. So before we start building the application, we need to deploy it first in some place. So where should we deploy that in this model? So we'll deploy this model in a place which we call as Azure AI Foundry. So those who are have been exploring the Azure AI world knows that we used to have this with a different name, and I'm going to show you that over here. So if you see, this is the Azure portal. where you go ahead and create an open AI this thing. So you can say, let's say I go ahead and create an open AI thing. So let me go ahead and say Azure OpenAI. I go and create that over here. And then once I create this over here, I go into this, any one of them, and then go to Azure AI Foundry portal. The easiest way is to remember like ai.azure.com. So if you are in portal.azure.com, you basically move to ai.azure.com and it becomes the Azure AI Foundry. Now if I may go to this home page and then view all resources, you'll find that there are many resources which are created already. So let me go into that. And then one of them is the AI Foundry project. So how do you create this project and how do you come up with that thing? So let me show you that. If you go to the home page of this, so let me go here. And then what you essentially can do that you can click on this model catalog and you see that there are all native models available. The models which are basically available in Azure will be deployed in Azure using the Azure thing. So these are all open source models, but it also allows you to create projects with other models. So if you click over here, then it becomes a bit more bigger. So earlier it was around 23 models. Now you can see that you have got around 1,829 models available, including those open source models. You have got your couple of preview versions of the models, which you can see over here. It's a huge list. And one of the models which you can search here, let's say, you can use this R1 model. And once you select this R1 model, it asks you to deploy. It also gives you a couple of additional information. Now you have got a content filtering just to protect what kind of input and output you can send to or receive from this model. You basically say that deploy this model. Once you say deploy this model, either you create a new project. Once you create a new project, it will be appearing. If you already have a new project, you select a project. So right now I have only one project. So I select the project and then it basically asks me a couple of things. So I give the name, the deployment name, and you can see the pricing and terms. It is right now priced $0. Okay, because it's still under. So it's a high time that we all go and play with this model, right? Because you don't have to pay anything for that using this model. And then if you go to the overview, you see that there's a content filter, which is still under preview, is by default enabled, which essentially means that the thing which you provide is highly controlled, in a sense like you can't have a racial comment or something harmful thing, abusive language. Anything you do wrong will be prevented by the content filter. So it's a capability within Azure. So you can enable a content filter for your application also. So you can use that as a service. So we are using that same content filter capabilities. And it has a server. You can see that. I'm just going to highlight it. Maybe I'll increase the font size. It's a serverless API and it's available in region like East US 2, West US 3, North Central US, East US, South Central US, and West US, mostly in United States. So this is, if you are looking for deploying it into your region, which is not available, probably we have to wait for some time till it is available. But this is kind of like right now limited to only these regions. And then you can see that it also mentions that it is provided by Microsoft as a first-party consumption service. So what you get here in the Azure AI Foundry provided, and then you can actually learn more about model as a service in the AI Foundry portal, and then what all things you can go a bit deeper to understand the supportability, etc. if you wish to know a bit more about it. The model announcement has been done in the GitHub, so I'll show you that announcement. So you can see it's an official GitHub page, and they have actually got the announcement over here. What we are using, the R1 version, they have announced the number of parameters is 671 billion, right? And then it is also available in Hugging Face. So in case you have a GPU machine, you can use it from the Hugging Face to deploy this model. There are container images available for that also. So you can deploy that to Azure Machine Learning Studio if you wish to deploy it in your own container and use it from there using the so there are many other information available. You must go and check it out over there. But let me show you that what I have already created. So I go to this. I go inside the project which I already have created, and then if I go into the models and endpoints, I'll find the model like I created by myself. If I go into this model, you also have a playground, which essentially you can try out things, benchmark with other models, etc. So if you can see that, tell me 5 best non-fiction books in English. So if I type this, right? So it's kind of like the conversations or the chat. So it starts thinking about that, and right, and it'll slowly appearing, and then with the reason it'll explain you what it is doing. So this is default. I haven't written any single line of code. So this is available already in Azure AI Foundry. If you click on the view code, you'll be able to see the way you can write this code. And then you have different programming language. It supports Node.js, right? And then Python, C#. So all these different kind of programming languages you find. You can even go to the GitHub. There is a nice little portal available in GitHub to play with these models. So you can see that it's still thinking and then typing. So sort of like coming in sort of stream. So it called out the Sapiens by Yuval Noah Harari, who is one of my my favorite ones, right? Educated by Tara Westover. This is also a very good book. So there are books coming in, and then the list is yet to be created. So it's thinking, it's analyzing, just like human being. If you ask me the same question, I'll also scratch my head, start thinking, start recollecting my memory, all the books I have read. Probably I will not be able to remember all of them, but I will try my best to do that, and I will come up with, let's say, 3 to 4 recommendations. And this is doing exactly the same thing, because the reinforcement learning, which has happened already, has got this capability. And we talked up briefly about how the execution of the model happens behind the scene, right? So these are all documented, officially documented. So we are not making out anything. So this, you can see now you have got 5 books, and then you see here that thinking fast and slow. There's also an economist, Nobel laureate, who wrote this book, Sapiens, Educated, and then there are 2 more which I haven't read. So common 3, yay. All right. Now what I'm going to do now, I have this thing. I will go to the model and endpoint. I need to use this URL. That's my API endpoint. And then I need to use this key for connecting this from my application. And then I need this name, that is the model name, 3 things. So I go into, let's say, one of my Visual Studio, and I'll show you how this can be written. So there's a sample environment. So I kind of have created an three environment variable. Either you can have it in your operating system environment, or you can have a text in a text form. You can load it from the text file and then read it just like an environment variable. Benefit of doing this kind of approach in typical Python is that if you, let's say, build a Python-based solution which is container, and then you can pass it as the parameter while deploying the container, so and keep changing those values. It's not hard coded within the application basically. So imagine that you are deploying it in Kubernetes cluster. You can use the Kubernetes secrets or different approaches of storing the Kubernetes variables outside of the Kubernetes pod, and then call it from that. So basically, like, those things are can be changed at a runtime level. So that's what we are doing. So I'm not going to open this env because it has got the real value, but it has basically coming from .env file. Now let's show you the Jupyter notebook to begin with, right? So you see that I needed two major library, Azure AI Inference, but I would like to show you what exactly that means. Okay, so let me give a quick moment and then bring that Azure AI Inference API documentation available in the official portal. So it basically has got capability for following models, and this is the last one. Sorry, this is the last one. You can see that. So it works with all these models, and all these models are available in Azure AI Foundry. The way I just deployed this last one, the DeepSeek-R1 model, you can deploy these models in the Azure AI Foundry as well. And then write the simple Python code because you are using the same API for everything. So it becomes easier for us to not get into different SDKs and those things. I find it very convenient rather than figuring it out for each of these models natively. But essentially I need to go back to my Visual Studio, and I need this, and I need this python.env to read from the environment variable, and then these are the libraries I'm going to use. So you can see that it is basically using Azure AI Inference, models, credential, and once you basically run these, let me run this, and then you now need to read the value from the environment .env file, or if it is an environment variable, you can see that getenv can read from the value from the environment variable. If it is both Windows or Linux and you're running this Python script as a script and you have these variables stored in environment variable operating system, it can still read. So you can change the URL and the token, whatever you want to use for the same code base. The code base doesn't require you to touch that. So let me run this, and I'll see that it's reading this value. So it's right. We are reading the right file. That's fine. If you change anything in the environment variable in a Jupyter notebook context, you need to just restart the kernel. And then you start from the beginning, load the file again, you will have the reflected value. But a lot of time we change and then we forget to restart and doesn't reflect. So that's why I put a print here to make sure that it is reflecting. And then you initialize this chat completion client with the endpoint and the token or the secret or the key. So I basically gave a name called token, but you can call it key, you can call it secret, whichever suits you. This is just the name of the variable. And then you basically initializes the chat completion client. If you look into the basic, right, I asked one simple question. What is the capital of France? And then it starts reasoning that question into multiple different steps. So it basically categorized that. So why I did that? Because the execution time takes around 1 minute 20 seconds for this. Okay, that could be very boring if I run it and then wait for no output. That's why I did run it, and it gave me this. So it is not, let's say, properly wrapped text. So it's a long one, but essentially you can see that it doesn't give directly the Paris as an answer. It takes some time, it thinks, it reasons, it figures it out, and then it comes up with an answer. It's the case for everything. Now for an end user to wait for such a long time, 1 minute 20 seconds is a very long time for a web user. We are very impatient people. We don't want to wait for such a long for an output. So what essentially DeepSeek also allows us to do is that it allows us to stream the response. So if I take this same question, maybe, okay, I copy this same question and I paste it over here. What essentially it could do is that now if I run it, it'll start showing you the output as soon as it hits the endpoint properly. And then the thinking process, you can be with the thinking process. So you can see that the thinking is going a bit longer, right? And the line has been generated, right? So you can see that it is kind of coming slowly coming. So it is not making you wait for 1 minute 20 seconds to give you the output, but it'll slowly coming, right? So that's why you probably would take that stream approach. Now I took the stream approach and built a very simple Streamlit application, which I have explained in my video series of developing AI-based application using Python and Streamlit in a much detailed fashion. I'm not going into that. Rather, I'm going to stop this and run another file, which is this file, DeepSeek Web, which uses the Streamlit and then basically calls a couple of Python function written in the deepseek.py, and then you can see that it's just gonna give me the result. So let me run this command locally. This is running locally. Streamlit run and then run it, and it should pop up this open browser, and the browser opens. You can see localhost 8501, that's a URL it has. So I'm running this. Now I can say what is, let me copy paste, what is the capital of the France. Now if I run it, now you can see that as a web user, you will see the thinking process slowly. Like imagine that I'm babbling and thinking, I'm talking and thinking, and I'm telling what I'm thinking. This is exactly it is doing. So it's quite engaging. In fact, I feel that this is quite engaging rather than you are getting a very quick from the memory output. You essentially have that deep thinking going on, right? And then it is also thinking from a different perspective, like USA has Washington, D.C., not New York. So Paris might not be the capital, but I think this case it is, hold on, should I double check? So you can see that it is also telling you what it is thinking. And then it's kind of going in all different possible options. What about Bordeaux or Toulouse? All right, no, there are different regions. Let me think about the government building, like the Eiffel Tower in Paris, and all these things. Then, and finally, the capital of France is Paris. The city is not only the political center, but also the cultural institute. So it's adding some value because it kind of thought through and then came up with this context here. Now, this is a very straightforward answer, but right, we might not know. Now, let me show you something very interesting. If I see that, what I did over here, let's say, how can I build a Python-based Streamlit web application for this and deploy in Docker container. So let's say whatever I showed as a demo, I asked this question, very simple question, but then it becomes a bit more engaging, right? It's not a very straightforward one-word answer. It has to tell me the steps, and it will tell me when it is. So let me. All right, so it got closed. So let me reopen that. Okay. Let me run, come back, and then refresh it. Now it should. Oh no, it's gone. All right. So build a Streamlit Python web application using and deploy as a Docker container. We'll copy this and then I submit this and it starts thinking, right? And it starts thinking, and it also is very engaging. Imagine that I'm working on this project and I want somebody, I'm asking my mentor that, you know what, this is what I'm thinking. What do you think I should take an approach? And that's the kind of human conversation which got kickstarted, right? So you basically start thinking together along with this AI model, and it's also explaining how it is thinking. Now, it is also telling you the DeepSeek-R1 model is a Hugging Face model using the transformer. So it is also talking about that application setup. And it also tells you step-by-step approach. So you create an app.py, that's typically the Streamlit uses. I haven't used that, but this includes the UI, title, input, button, inference, model loading. You can, how do you load the model? You can be very specific. Like you say that I want to deploy it in Azure AI Foundry, that the model will be deployed. So it will tell you the steps to deploy it in Azure AI Foundry. Wherever there's a public documentation available, it takes that understanding and then uses them. And then the Docker file creation. So these are the kind of like high level steps you would be doing. Now it is how you need to do, right? It's sort of like it uses that port 8501. It knows about it. So we are using the same port 8501. It has got dependencies, right? Like using a GPU image is necessary. So you can't deploy this model into any virtual machine. It has to be a GPU heavy virtual machine, generally the NC series, right? So, and then building and running container, the Docker image. So where and what kind of host, we haven't specified whether it's in Azure container registry, we will host that image and run it from, let's say, container app. We could even say those things. If we would have said those things, it would have been more specific about how to do that and how do you do the testing. It even also tells you about like the Docker file, which comes from the Streamlit's official portal. I use the same Docker file, just modify the file name a bit here and there, and it works. So this is coming from the Streamlit official portal. And then how that app.py would look like. This is also giving you the code. So you are not only thinking from an architecture perspective, but also getting help from an implementation perspective. This is one of the greatest ways of like having a conversation with someone who is sort of like a go-to person or senior person who can help you understand like what all you need. So you can see that it also generating requirements.txt, right? And then it also have a Docker doc ignore when you build the Docker file. Use the Docker ignore not to take those files into Docker images. And then you have that Docker build process. How do you run the Docker container using the port mapping 8501? And then it also gives you those Docker commands, essentially, right? It becomes quite easy. And you can see that it also gives you like, how do you do the cloud deployment and how do you optimize them? Now, you can see that it is kind of bit generic in the sense I was not very specific about this question, but I can be very specific. Like I will build the Docker image, store it in Azure Container Registry, deploy it as a Azure Container App or Azure Kubernetes service. And then I can say all those different things like the model will be deployed in Azure AI Foundry. I will use Python. And then it becomes like a sort of that step by step. So it's a sort of like a blog, right? It's done. Sort of like a blog. You can see that it generates. So this is one of the greatest ways of thinking things, right? And you can see that if I may go back to my source code and close this and stop it somewhere, and I show you this. It is how many lines? 30 lines of code. Okay, here, and if you see this is the utility file, maybe the actual web which you saw is just 20 lines of code. Okay, that's it. That's it. The application is up and running. So within 100 lines, you have DeepSeek-R1 model deployed in Azure AI Foundry, getting called and executing, and also getting displayed the thinking process. It's a very simple way to do a proof of concept using this DeepSeek. Hope you have enjoyed, and thank you for watching.